Hurricanes are one of nature's most destructive forces, killing thousands of people every year, all over the planet.
A single storm going into Bangladesh not many years ago killed almost 500,000 people. That's a lot of people. It's a colossal, horrible thing. Even in this country, we've seen Katrina take the lives of somewhat over 1,500 people.
And scientists predict that because of the effects of global warming, there is much worse to come.
As the ocean temperatures warm up, we now have more energy available for these hurricanes to develop. So where a hurricane might have been a Category 5, in current climate, maybe we have to invent a Category 6.
It's not just a problem for the United States. China, India, Japan, and many other countries are vulnerable to these storms. And as the storms get bigger and the death tolls mount, there will be increasing pressure to act. A radical idea from the 1950s, long discarded, is once more being taken seriously. The idea of hurricane modification, finding ways to weaken or deflect a hurricane before it hits shore.
I think that the technical barriers are not nearly as large as the social and political barriers, because we rightly don't easily want to tamper with Mother Nature.
In fact, much of the technology may already exist.
We've done simulations with Hurricane Katrina, and we still had the strong winds, we still had the deep cloud systems, the rainfall. However, what was a little bit surprising is that there seemed to be a few degrees change in the path of the hurricane.
Just how close are scientists to controlling superstorms? And what are the risks of playing God with the weather? The coastline of the United States is frequently battered by hurricanes. Perched right on the tip of Florida, Miami is one of the East Coast's most vulnerable cities.
How's the thing look near Africa?
Dr. Chris Lancy is a meteorologist in Miami's National Hurricane Center. He has experienced the devastating force of hurricanes at first hand.
The biggest personal interaction I've had with a hurricane was Hurricane Andrew in 1992. I was actually studying hurricanes for graduate school when Hurricane Andrew hit Miami and my home.
The hurricane hit Florida's east coast at 5 a.m., with winds gusting up to a terrifying 160 miles an hour.
I came down after the hurricane to see what had happened and to help clean up. And I was just shocked to see that my neighborhood, my area, was essentially bombed out.
I wouldn't believe that wind alone could do that.
20 miles south of Miami, and this is all that remains of a low-rise housing estate.
All the trees, a large majority of the houses had either partial or full damage. A portion of my parents' house, the roof, a third of the roof had been lifted up by the winds and carried about 2 blocks away. It was an eye-opening experience for me because in the past, hurricanes had just been something I studied in school. And yet here was one that directly impacted my family. I was very fortunate that no one had been hurt or killed. Still to this day, Hurricane Andrew's impact is felt by many people.
To understand why the US coastline is so vulnerable to hurricane strike, you have to travel over 4,000 miles east to the place where hurricanes are born. Most hurricanes in the Atlantic begin as very small atmospheric disturbances in the jet stream that flows from east to west over sub-Saharan Africa. Scientists call this disturbance an easterly wave.
What triggers the development of an easterly wave could be anything. Could be a little girl playing in the sand. It trigger off a little dust devil, for example, that perturbs the atmosphere downstream in such a way that you get one of these waves.
The easterly wave creates a system of turbulent eddies, which go on to develop into a cluster of thunderstorms. These travel west across the African continent and then encounter the warm tropical waters of the Atlantic.
One begins to see on satellite pictures is these thunderstorms appear to become better organized and begin to rotate around each other. The rotation rate increases, the storms become more vigorous, and the winds continue to increase.
The storm rapidly gathers strength and develops into a hurricane, feeding off the warm, moist air coming from the ocean.
The heat is coming out of the ocean. The hurricane heat engine converts that heat energy into the mechanical energy of the winds. And that's what's powering the storm. When the winds reach typically around 70 miles per hour, the storm may develop an eye, surrounded by an eye wall, which is a region of very intense heat and the strongest winds. And you're off and running.
These are the hurricanes that make landfall on the US every year, causing enormous damage. The disturbing thing is, a new trend in hurricane behavior has recently emerged, which scientists believe is linked to global warming. Professor Greg Holland is a leading authority on hurricanes who's been investigating these claims.
Some statements have been made by other scientists on the effects of global warming, and we decided to just go back and look at the entire record of hurricanes around the world going back to 1970.
He collected data from hurricanes in the Atlantic, typhoons in the Pacific, and tropical cyclones in the Indian Ocean. He analyzed the frequency and intensity of these storms over a 30-year period to see if he could detect any noticeable change in their behavior. What he discovered was both controversial and shocking.
We found that over the last 30 years, the proportion of Category 4 and 5 hurricanes had nearly doubled. The increase in the Category 4 and 5 hurricanes is consistent with global climate change because as the ocean temperatures warm up, we now have more energy available for these hurricanes to develop. And that means that hurricanes are going to be meaner, more intense, doing more damage. Where a hurricane might have been a Category 5 in current climate, maybe we have to invent a Category 6.
NOAA is predicting an above normal hurricane season with 13 to 16 named storms, of which 8 to 10 are predicted to become hurricanes, and 4 to 6 of those hurricanes are predicted to become...
This worrying trend has led people to ask whether anything can be done.
One question that comes up all the time is, why can't we just get rid of hurricanes? You know, we're so smart, you know, can't we figure out a way to steer it the other way or get rid of it completely?
Theories on how to combat hurricanes are constantly put forward by well-meaning people to staff at the National Hurricane Center.
We often get ideas, for example, let's tow icebergs from the Arctic, cool the waters down. The idea of towing the icebergs is sound physically, If you do cool the ocean temperatures by 5 or 10 degrees, you would weaken the hurricanes. But the practicality is that you would need all of the large ships in the whole world to constantly be towing icebergs down to have enough cooling effect to really have an insurance that hurricanes would be weaker. Another idea, let's hit the hurricane with a nuclear bomb. But that doesn't take into account that each hurricane produces the same amount of energy, if not more, than all of the electrical generation capacity of the whole Earth. So if you toss a nuclear bomb in, it would have no impact. And then the problem would be you'd have a radioactive hurricane moving ashore. I don't think that's something anybody would want.
Not all ideas are so far-fetched, however. One of the world's most respected hurricane physicists, Professor Kerry Emanuel of MIT, believes the answer may lie in copying nature.
The idea begins from an observation that many hurricanes are steered harmlessly out to sea before they ever hit land. And that happens because of an accident of the weather, if you will. There are constantly weather systems forming and developing and moving across the country, giving us what we know as weather. And if one of those weather systems happen to be coming along when a hurricane's approaching the state, that weather system will interact with the hurricane in such a way as to steer it offshore.
This process was captured by a NASA satellite in 2005, when Hurricane Ophelia was whipped back out to sea by a weather system moving in from the northwest. So would it be possible to artificially create a weather system capable of deflecting a hurricane? Professor Emanuel thinks it could be done by harnessing the science which governs the atmosphere. Chaos theory.
It's a bit hard for people to grasp how sensitive the atmosphere is. Ed Lorenz, who is widely regarded as the father of chaos theory, illustrated it with the notion that a butterfly flapping its wings in Peru might several weeks later lead to a tornado in Texas. It's very, very hard for people to realize that this is not a metaphor. It's really true.
The atmosphere is a perfect example of a chaotic system. This means that very small disturbances made in one place set in motion a chain of events that can result in very large-scale changes in the weather somewhere else.
So the notion then becomes, can you tame that butterfly? Can you introduce a butterfly just the right place at just the right time to have a desired effect? Well, here's a plausible scenario. The first step is that you run a large computer program, and then it tells you that if the hurricane now approaching Miami is to avoid Miami, you need to seed the atmosphere somewhere over the eastern Pacific Ocean west of the United States. So then you would send out a fleet of aircraft, specially designed aircraft, which would put out a set of contrails of, let's say, fine black carbon dust, environmentally safe, in a sheet that slopes westward with height. That sheet, which might be 1,000 miles long, but not very wide, would subsequently absorb sunlight and introduce a very small temperature perturbation, a 0.5 degree temperature perturbation.
If you scatter carbon dust into the sky, it will, being black, absorb sunlight and slightly warm the air. If done correctly, this small temperature change, or perturbation, can lead to large-scale effects.
The atmosphere would naturally amplify this temperature perturbation, and as it moves toward the east over the US, the system would cause a normal kind of weather system, a low pressure area that we have all the time, but this sort of now happening where and when we want it to. And 3 days later, it begins to interact with our hurricane and steers the hurricane offshore. so that it never hits land. That's a actually plausible scenario.
This idea, although promising, has yet to be tested in the real world. There is, however, another approach to hurricane modification that was first tested back in the 1960s, following a series of devastating storms.
Hurricane Agnes takes 134 lives.
If only the force of the hurricane's winds could be reduced, the toll in death and damage could be greatly lessened. Is there a way? Project Storm Fury, a joint effort of NOAA, the Navy, and the Air Force, is designed to try to find one.
The time that Storm Fury began was at a period of optimism in how we could beneficially control the weather.
Scientists working on the project were convinced that they could reduce hurricane devastation using a process called cloud seeding, by spraying the thunderclouds inside the hurricane with a chemical called silver iodide. This would become known as the Storm Fury hypothesis.
Seen from directly above, the center of the hurricane is called the eye. The dense ring of clouds around the center is the eye wall, where large masses of warm, moisture-laden air rise from near sea level to great heights. Water vapor condenses in vast quantities. Some of the condensed droplets are carried aloft where temperatures are below freezing, but continue to exist as supercooled droplets. The seeding planes fly across the eye and into these clouds, seeding the supercooled water droplets from the belt of maximum winds outwards. The silver iodide acts to transform the supercooled water droplets into ice crystals, upsetting the delicate heat balance of the storm.
As the silver iodide turns the supercooled water into ice, the heat released during this process causes the seeded clouds to grow and develop into a new outer eye wall.
And the idea was that outer one would contract in and essentially squeeze off or strangulate the inner one. And as it does that, the hurricane weakens. So the theory is right. If you can make the outer part a little stronger, you make the very dangerous inner core, the eye wall, that's weaker.
They had their theory. Now all they had to do was put it into practice. In August 1969, Hurricane Debbie was born off the west coast of Africa. It was the perfect storm to test their ideas on. Dr. Robert Sheets was one of the scientists who took part in this remarkable experiment.
And we're all nervous. I mean, I don't care, anybody that was on that flight was nervous before we ever got there, because we knew we were going to do something very dangerous, pushing the airplane to its limits.
On the 18th of August, the scientists left Puerto Rico Air Base to meet Hurricane Debbie. The plane was heading towards the eye wall, the most dangerous part of the hurricane, where winds can reach an incredible 180 miles per hour.
You could see it on the radar there. You're watching the instruments, watching the radar. I just sort of kept waiting, you know, what's going to happen here? And I'm holding on my seat, when's it going to hit? When's it going to hit? And then all of a sudden, shoot.
Looks good. Think we got the center.
Once inside the eye wall, Bob Sheets' job was to measure wind speeds before, during, and after seeding.
We flew back and forth through the core of the hurricane in a figure 4 fashion. We measured that the wind speeds, maximum sustained wind speeds, are about 115 miles per hour. We then start seeding, and continually monitor the storm throughout this period and for the next few hours after the seeding had ended.
Robert and the team were astonished by what happened next.
And the end result was that the wind speed was now down below 100 miles per hour.
The seeding appeared to have worked. To be sure of this, the scientists repeated the experiment to see if they could replicate these results.
Now we leave the storm alone for the next 24 hours. It now regains the strength. The eye wall gets better defined than it was on the first day, as a matter of fact. It's now back up to 115 miles per hour maximum sustained winds.
They seeded the clouds once more and again witnessed a fall in wind speeds inside the hurricane.
And by the end of that experiment, it's down to about 100 miles per hour. This reduction doesn't sound like much, but if you can take a Category 3 hurricane and make it into a Category 2 hurricane, there's a tremendous difference in the damage that's done, even though the wind speed has only been reduced 10 or 15 miles per hour.
So impressive were the results from Hurricane Debbie that many scientists recommended that in future, every hurricane likely to hit the coast should be seeded.
They even went so far to say that if the government does not seed a hurricane with this technology you've developed here, if they do not seed a hurricane making landfall, then you ought to be liable for the damage that it's done.
The US government quickly allocated $30 million to further their research. But ironically, what they were to find would spell the end for Project Storm Fury.
Fire 3. Fire 4.
Flying again and again into storms, they discovered something no one had suspected. Eye wall replacement can occur quite naturally in hurricanes. It was impossible to prove whether seeding triggered eye wall replacement or whether it happened naturally. Project Storm Fury was brought to a close in 1982. The technology available at the time was simply not sophisticated enough to prove whether seeding made hurricanes weaker, stronger, or had any effect at all. In the last 30 years, all of this has changed. Computers, satellites, and new instruments on board aircraft have transformed our understanding of hurricanes.
We have aircraft fly right into the middle of the storm. They actually go right through the storm, usually about 10,000 feet above the ocean. And it launches instruments, we call them dropsondes, out of the belly of the aircraft to measure the entire atmosphere, the winds, the pressure, and humidity. And that sends that information back to our headquarters, and that gets into the computer models.
The detailed information provided by these computer models has made hurricane forecasting more accurate than ever before. Dr. Rolf Brunches from the National Center for Atmospheric Research is putting this information to a very different use. He's breathing life back into the science of cloud seeding.
Yeah, if you can see what the distance is, that would be helpful.
We've seen great developments in computer technology. We can put more of our physics into numerical models. We've seen great developments in terms of remote sensing, radars, satellites, that now provide us the opportunity for the first time to really look inside clouds, being able to see what kind of ice crystals, what kind of droplets there are in clouds. So these measurement capabilities give us now for the first time the opportunity to explain, if we get a statistical result, why it doesn't work or why it does work, and then quantify those results.
We asked Dr. Brunjes to re-examine the work of Project Storm Fury and test its hypothesis on a computer simulation of Hurricane Katrina.
After Hurricane Katrina, we had many requests, well, can we modify hurricanes? And usually when big hurricanes strike, these are the kind of requests from media, from all different kinds of people that you get. And so we thought we can do better than people could do during Storm Fury. So we just thought, well, let's go back to the original concept, conducting the seeding with silver iodide. So we decided just to do one very rudimentary run and freeze all the supercooled water at a certain stage and see what would happen to the hurricane.
Using a detailed model of Katrina, he was able to identify the regions that contained high concentrations of supercooled water and simulate the cloud seeding process in these areas.
The area in red here is the supercooled liquid water content. So what we do in a seeding simulation, we freeze all this water, turn this into ice crystals. So as you can see in the seeded simulation over here, we don't see any more supercooled liquid water content. This is all turned into ice crystals.
This transformation could, in theory, weaken the hurricane's strength. Dr. Brungies was skeptical that this would make any difference to the behavior of the hurricane. But it did.
Actually very surprising. It didn't seem to change anything in the intensity of the hurricane. We still had the strong winds, we still had the deep cloud systems, the rainfall. However, what was a little bit surprising is that there seemed to be a few degrees change in the path of the hurricane.
A few degrees doesn't sound like much, but in the case of Katrina, it would have meant that the hurricane would have been diverted 50 kilometers from its original path, producing a very different outcome. If this is the case, what is stopping scientists from testing seeding on a real hurricane? Could hurricane modification, one day, become a reality?
In the computer, we can do some tweaking. We can make it a little warmer, a little colder, make the winds a little stronger or weaker. If theoretically you could do such a tweak, and you could change the course of the hurricane or make it a little weaker. But if you don't get the tweak exactly right, do we know what's going to happen? And I don't think we really do.
If we really wanted to do it, if we said, we're going to do this the way we said we're going to put a man on the moon, I don't think it would take very many years to come up with the technology. I think that the technical barriers are not nearly as large as the social and political barriers, because we rightly don't easily want to tamper with Mother Nature.
In the next program, we explore the moral and ethical implications of weather modification through its controversial and checkered history, and ask the question, should we be playing God with the weather?
And that's at the same time next week, and if you missed BBC One's drama Superstorm tonight, you can watch it again here on BBC Two next Saturday at 6. Coming up, who's on their way to Wembley? The best of the day's football with Match of the Day 2.